In this video, we will be discussing similar figures. Specifically, we are dealing with the objectives of determining whether two figures are proportional or similar and finding the missing sides of two similar figures. Let's look at a definition of similar figures. Similar figures are figures where the corresponding angles are congruent and the corresponding sides are proportional. For our purposes today, we are going to focus on this aspect of similar figures, the corresponding sides being proportional. Let's begin by looking at an example of where that would be true. Let's say we have two triangles, the ever popular 3, 4, 5 right triangle, and its cousin, the 9, 12, 15 right triangle. If these two triangles are similar, then all of their sides will be proportional. Keep in mind what our definition of a proportion is. A proportion states that two ratios are equal. So if we match up the corresponding sides, we can check to see if everything has the same ratio. So what we want to do is we want to match up the shortest side with the shortest side. We want to match up the next longest side with the next longest side. And of course, we keep right on going. And that's how we can keep our correspondence together. So 3 matches with 9. 3 over 9 is one ratio. I check the next one. 4 to 12 is the next ratio. And the final pairing, 5 and 15. Now if I look at all three of those ratios, they are all equivalent. 3/9 reduces to 1/3. 4/12 reduces to 1/3. And 5/15. Oops, that should be a 15, not a 12. 5/15 reduces to 1/3. Because all three of these are equal, then the sides are proportional. So the triangles are similar. Now technically we got to make sure that our angles are congruent, but we're going to assume in this example that our angles are congruent and focus on the proportional sides. Now let's look at some examples where this gets to work. We've got two sets of triangles here, and we are trying to determine whether or not these are similar triangles, or we could be asking, are these sides proportional? In number 1, I'm going to make all of my matchups here. 7 corresponds with the 35. Those are the two shortest sides. 9 matches up with the 45. That's the next side. And 15 matches up with 75. Shortest, second shortest, longest. And I want to make my ratios now. 7 over 35. 9 over 45. 15 over 75. And if I reduce every one of these fractions, this reduces to 1/5. This reduces to 1/5. This one also reduces to 1/5. All the sides are proportional, so yes, these triangles are similar, or at least we know their sides are proportional. Number 2. Push pause for a second and you test number 2. Alright, when I do my matchups, 6 matches with the 12, so I have 6 over 12. 10 matches with 21, so I have 10 over 21. And 11 matches with 22, so I have 11 over 22. The question I have now is, are these sides proportional? Do all of these ratios reduce to the same ratio? 6 over 12 reduces to 1/2. 11 over 22 reduces to 1/2. But 10 over 21 is as good as it gets. These are not all the same, so no, these triangles cannot be similar. Let's talk about something called a scale factor in similar triangles. Scale factor, here's the definition, is the ratio of corresponding sides of similar figures. If we look back at our previous example, the ratio of the corresponding sides here, we can take any set and just reduce it. 7 over 35, 1/5. 9 over 45, 1/5. 15 over 75, 1/5. In this case, the scale factor for this set of triangles equals 1/5. And our first set of triangles all of these ratios reduce to 1/3. 1/3 is the scale factor for these triangles. So the scale factor is the ratio of corresponding sides of similar figures. And that's important for what we will do next, because knowing our scale factor will enable us to move to our second objective and find the length of the missing sides if we've got similar triangles. So in this diagram, we've got two triangles. The triangle on our left has sides of 8, 12, and 14. And the triangle on the right has sides of x, y, and 21. I would like to know what x and y are. I can figure that out on the basis of the fact that these are similar triangles and I can use my scale factor. Now let's match these up. I'm going to color code these. 8 will match with the x. 12 will match with the y. And 14 will match with 21. So I can set up three ratios. 8 over x, 12 over y, and 14 over 21. If I look at these, in only one set of ratios have I got both numbers, and that's this one right here. That'll tell us what our scale factor is. If I reduce that, that will reduce to 2/3. That's the scale factor of these two triangles. And I'm going to use that now to find x and y. 8 over x should be equal to my scale factor. Now I have a simple proportion. I'll just use my cross products to get the solution. 8 times 3 is 24. 2 times x is 2x. I divide both sides by 2, and I get x equals 12. So there's one of my missing sides. I'll do the same thing to find y. 12 over y equals 2 over 3. I'm going to do my cross products. Y times 2, 3 times 12, 36 equals 2y. Divide both sides by 2, and I get 18 equals y. So the missing sides of this triangle are 18 for y and 12 for x. Let's do one more together before you attempt to do some on your own. Looking at this set of triangles, 5x and 6 are these sides, and 7.5, 12, and y. X and y are in different triangles, but that's okay, because we can still make up our ratios. 5 matches with 7.5, so I have 5 over 7.5. X matches up with 12, so I've got x over 12, and 6 matches up with y, so 6 over y. Something important to make note of is sometimes your variable will be in the top, sometimes it'll be on the bottom. It all depends on which triangle we're in. If I always list my left-hand triangle on the top, then I do that whether it's a variable or a number. The x was in the left triangle, so that's why it was on top. The y in this case was on the right triangle, so that's why it was on the bottom. Okay, if I look at these, I've got both set of numbers for this one. And this one might be a little hard to try to see how it reduces, so if you can't reduce it, that's okay. You can use a calculator to do your computation. But this would actually reduce to 2/3. That looks a little familiar. That's exactly like our last problem, I believe. But let's pretend that we don't know that this reduces. And let's just do it with the decimal and find our x and our y. So 5 over 7.5 equals x over 12. I'm going to do my cross products now. And I've got 7.5x equals 5 times 12 is 60. Now I have to divide both sides by 7.5. And 60 divided by 7.5 will give me 8. So x is equal to 8. Let's find the y. Our scale factor is 5 over 7.5. And our ratio including y is 6 over y. We're doing our cross products. And we get 5y equals 45. Y is equal to 9. All right. Here's one that you should try on your own. Push pause, see if you can figure out what x and y are in this particular example. All right, welcome back. Let's match up all of our pieces. The y goes with the 24. The x goes with the 20. The 18 goes with the 36. So all of my ratios are 18 over 36, y over 24, and x over 20. In this case, the variables are on the left-hand triangle. I've always got my left-hand triangle on top. 18 over 36, that reduces for us. That'll make life a little bit easier to 1/2. So I set up my proportions. 1/2 equals x over 20. And that'll tell us how to get x. When I do my cross product, I get 20 equals 2x. Divide both sides by 2, and we get that x is equal to 10. To find the y, 1/2 equals y over 24. Do the cross products. 1 times 24 is 24 times 2y. Divide by 2, and we get 12 is equal to y. I hope you got that one right. Let's do one more. Try this one on your own. We have two triangles. Triangle left, sides 15, y, and 21. Triangle right, sides 25, 15, and x. Push pause. Try this problem on your own. Okay, so let's match this up. 15 matches with the 25. Y matches with the 15. The other 15 in the other triangle. It's going to be important that we keep these two separated. And 21 matches with the x. So here's my ratios. 21 over x. 15 over 25. And y over 15. This y over that 15. This 15 over that 25. We got both numbers for this one. That's going to reduce to 3/5. Now I can set up all my ratios. 3/5 equals 21 over x. And if I go ahead and set up my other one, 3/5 is going to be equal to y over 15. And now I can solve each proportion to get my x and y. 5 times 21 is 105, and that's equal to 3x. Divide by 3, and I'll get x is equal to 35. In this case, I have 5 times y is 5y. 3 times 15 is 45. Divide by 5, and I get y is equal to 9. So that's the two missing parts of this diagram. So to recap, similar figures have corresponding angles that are congruent, but the part that we're going to worry about right now is the fact that their corresponding sides are also proportional. The ratio that creates that portion is called our scale factor. And we can use that scale factor to set up all of our relationships, set up our proportion, and find any missing sides.